Welcome back to Connect and Transform. In today's video, I'm going over some code that I wrote yesterday to simulate a digital rain kind of effect, similar to what's seen in the movie The Matrix. One of my goals for this project was to complete it in less than 100 lines. Of course, the whole document could have been put into a single line with the same behavior, but it would not have been readable. And if I had added another 20 or 30 lines and a couple more functions, it would have been a lot more readable. If you look at the bottom center of the screen, you can see that it was completed in exactly 99 lines. And you can see every single character in the document except that where we're defining the alphabet, that runs off the screen. Temporarily, I'm going to edit this line and remove a lot of characters from the alphabet. So now on the right-hand side of the screen, you can see every single character in this script. And I'm going to refresh on the left. And now we see that because we shortened the alphabet, everything shown on the screen is only from that alphabet. So now briefly, let's talk about the languages used and the major dimensions of consideration. And then after that, I'll just copy some code over into a new file, and then we'll slowly demonstrate it and build it up until we get to the finished product that you currently see. So the document itself, we have our SVG root. As far as XML, that's all at the bottom of the document. It's just these three containers. So we have a black rectangle that fills the screen, and then on top of that, we have a text container to hold the grid of background text that is the very muted, very dark green. And then we have a text container to hold the vertical lines of text. In reality, it's really two grids of text, but they appear to be vertical lines based on the spacing. And then the majority of it is JavaScript, and just for the purpose of variation, not for any other particular reason, I chose to encapsulate the entire thing into this constant called matrix rain. And that encapsulates everything except for this line, which calls matrix rain.init. So that's just a nice way to, again, encapsulate things so that you don't have potential, global variable clashes. Now, I realize that's not really a concern in this instance because we're talking about a script inside an SVG. So it's going to be in its own document that gets embedded into a parent document anyway. So I'm not doing this to avoid global variable clashes. I'm doing this just to retain some understanding of how to do it, because there's a lot of different ways to structure things in this language. So for example, the init function, instead of saying function init, you're defining init within matrix rain to be a function. So things like that. As far as major considerations, I wanted to be able to import an external font file. I know there's fonts available that basically copy the characters from the matrix, but I didn't use that one because it was not free for commercial use, and so I just didn't want to risk it. So I found this font from Google Fonts called Noto Sans Math, and it had a lot of mathematical operators. And so the majority of our alphabet is these mathematical operators, and then I just added the digits 0 through 9 as well. In fact, I'm going to go over to the left-hand side of the screen. Now that I've restored the alphabet to its original character set, I'm going to refresh. And so now you can see the vast majority of it is just mathematical operators. Okay, now let me talk briefly about the different dimensions of the rain. So I'm calling the lighter green vertical strings of characters, I'm calling that a rain chain. And then within the rain chain, it's made of raindrops. So basically a raindrop is just a single character piece of text. Okay, and then these rain chains, they have a lot of different ways that they vary. So the length of the text varies. So I have an equation, an expression there to calculate the length of the text. And then we have a function called create text, and that also uses an expression to pick a character out of the alphabet. So our content in terms of the literal character varies. The total length of the range chain also varies. And then we also have an expression to vary the scale within some range. We have an expression to vary the speed at which that rain falls. And then, of course, we want to vary the horizontal positioning. So basically, we're rounding it to within some unit. And we're saying if something already exists at this particular point, then we want to choose a different point. So that's why we have this while statement. We're basically just hunting around using math.random until we find a horizontal spot in the board that is not currently in use. We're also modifying the number of visible drops at a given time. So let's say that a rain chain has length 10. The visible drops at once might be 10 or it might be 1. So if the visible drops were 1, then the rain chain would start to decay or disappear before it had even completely been created. I also have a dimension of lifespan. So let's say you have a rain chain of length 10, so all 10 get created. And then there's going to be some additional delay, and that's what the lifespan is the additional delay before it would start to decay. And all of these different dimensions interact with each other. So for example, visible drops at once, lifespan, depending on whether these are minimized or maximized, they might accentuate each other or they might conflict with each other. And then we're using all these various constants. We're then, compiling that into an object that we're passing in as we create a raindrop. And so as we create this text, we have all the data about the rain chain. And then we also have the specific position passed in. So briefly, I think I'm going to start by just copying the minimal stuff here. So let's copy the SVG document and the main structure into a new file. We'll scroll down. We'll copy our main structure here. Okay, so this is the entire document minus the script. And I think if you've watched my previous videos, this is all going to be very self-explanatory, so I'm not going to speak to any of this stuff. And then we have our constant that encapsulates most everything. And so we will fill in that constant, and then we're saying that our constant is going to have an init function. So let's look at that init function. But first, we're going to copy all these variables, and I'll talk about them one at a time. So we're storing the text container element just to avoid doing unnecessary document queries. We don't necessarily have to store this. We're storing this SVG namespace string just to avoid having to type it out 2 or 3 times. Doesn't save us a whole lot, but it saves us something. We're keeping track of the screen width and height because we need the screen width so that we know how many horizontal positions there are in order to insert rain chains. And later on in the code, you'll see that we are arbitrarily saying that we're only going to have so many rain chains on the screen at any given time, such as to fill 80% of those slots. So we need to know the width to know when to stop creating these chains. And as far as the height, that has some impact on the expressions that control the length of the rain chains, and I believe also like the lifespan or something like that. And then we have some spacing functions so that we can space out the individual characters vertically and horizontally. And then we have spacing for the background grid. We're keeping track of how many rain chains are created so that, for example, we know that we don't have so many that we're overfilling the screen and we're doing work that has no effect. And then of course we have our alphabet of characters that we can display. And then we're keeping track. So we're using this horizontal spacing value of 20, and we're basically rounding everything to the nearest 20 and then adding that to the occupied horizontal space array. So for example, if the screen width was 99, then you would have 0, 20, 40, 60, and 80. So you'd have 5 possible places that a range chain might be positioned horizontally. And so this array might be up to length 5. And so this is just keeping track of which of those have been used. And then of course, once a range chain decays completely, then we remove it from the document completely. And we also remove it from occupied horizontal space. So that's an explanation of the constants. So now let's look at the init function. This is the one that gets called automatically. And so we're basically just setting some of these constants. We're making sure to get the actual screen width and actual screen height. And then we're going to create our grid of background text. So that's going to be the next function we'll talk about. And then we're going to create range chains from there. So let's look at create background text. So we've got 2 loops, X and Y. So we're traversing a grid that is fairly certain to fill the entire screen. So in the horizontal position, we are just taking the screen width and we're dividing by the grid spacing. That'll be approximately filling the entire screen width. And then same with the screen height. So across that entire grid, we're creating a text element. We are positioning it X and Y. We're giving it a fill value. Again, this is red, green, and blue. So there's no red, there's no blue, and there's a tiny bit of green. So it's almost black, but it's green. And then we're going to set the text content by calling this create text function, which we will look at later. And we're giving it a character length of 1. So we just want 1 character in this text content. And then we're appending the child. So temporarily here, I'm going to comment this out, and I'm going to save this file, and I'm going to go over here and refresh. And temporarily, we're going to assign it a value of, let's say, X. Okay, so now on the left-hand side of the screen, we see our grid. We see that it's filled with a very dark green, and the character is X. Now, of course, once we copy over the create text function, we'll see that it's choosing things more randomly. So we'll come back to create range chain and create range drop, but I want to grab this function, create text. Okay, so create text takes the length of the text that you want to get back. Starts out with nothing. And then for the length, it computes a result from the alphabet. So it's just using math.random, and it's just picking a character out of the alphabet, and then it's returning that result. So I'm going to go ahead and save. We'll go over to the left-hand side, refresh, and now we see, if you look very closely, I know that here, in fact, I'll temporarily make it much brighter. So there we go. Now you can see all these characters are created. We can also see that it's not entirely filling the space. So one thing I'm going to do then is I'm going to say less than or equal, less than or equal. So let me save that. Okay, now we have a more complete grid. So now the only functions that we need to look at are create range chain and create range drop. So let's look at create range chain. And so now we can restore this call inside the init function. So create range chain, what is it doing? So one of the things that I wanted to have happen is when the vertical rain chains are visible on the forefront is I want to have random mutations. So this first if statement here is handling random mutations. Now create rain chain calls itself right here with a small tiny delay. So essentially create rain chain is always running. But then we have a brief check here to make sure that we're not filling more than 80% of those horizontal positions with rain chains. We want to have some of the screen empty, but most of it filled up. So if we've filled up 80% or more, as rain chain is calling itself and running continuously, then we're just going to return and we're not going to actually create new rain chains. But when it is running continuously, we are running this first if statement, which is basically saying if any rain chains exist, then we want to get all the raindrops on the screen. So any raindrop from any rain chain, and then we're going to pick one to mutate. So we're just using math. So first of all, we're just using a query here to get all the raindrops, and then we're using math.random to pick a raindrop to mutate. And then once we have our mutated raindrop, we're going to change its content. Now, theoretically, it could be changed to the same character, but we're also changing its fill value to be slightly more aqua, more blue. So we're just changing the fill so that we can see that, yes, these have been mutated. So that explains the first bit of the function. And then as I briefly introduced at the beginning of the video, there's a number of dimensions and constants and expressions to calculate all the things related to the rain chain, which is then stuffed into this object called rain chain data. And so now we're going to create a rain chain. So we're creating a new group object called rain chain. We're storing the ID just for convenience so that we're not copying it into too many places and to keep the code visible in one screen. We are performing another expression to calculate the lifespan of the rain chain. And this relates to when the rain chain actually gets removed from the document, and then that occupied horizontal space gets freed. After we've calculated these things, we set the ID of the rain chain so that we can query it and refer to it later. And then we append the rain chain to the text container element, which is this text container down at the bottom. And then we make sure to add that the horizontal space has been occupied. So we're just pushing X into the occupied horizontal space. We're incrementing the number of rain chains that have been created because that is used in the ID so that every ID of every rain chain is unique. And then earlier, in all of our expressions and dimensions, we had calculated the length of the rain chain itself. And so this is where we have our loop where for every character in that rain chain, we're going to create a raindrop. And so we're passing in the rain chain with all its data, we're passing in the rain chain data, and we're passing in the actual position of the specific character on the rain chain. And then to finish out the function, we have a couple of delayed actions. And so they're based on the lifespan of the rain chain. And really these two lines were one line, but I just made them two so that they were fully visible at the same time. And so what is it doing? Well, it's querying the rain chain and it's removing it. And then the second line is making sure to free up that occupied horizontal space. So that's all that is doing. And then the only other function necessary is create raindrop. So looking at the create raindrop function, Again, it was passed in the rain chain data, and the position. So that's in the context of creating a raindrop, that is the container element, data, and position. So for each raindrop, there will be a delay before it appears and a delay before it disappears. So we're calculating those delays here based on, in this case, its position and its speed and its lifespan. And then we are creating our actual raindrop, which is a text element. We're setting a number of attributes here. So we're setting an ID, we're setting its vertical position using the vertical spacing, we're filling it with a intense green, and we are initially setting it to be hidden. And we're going to have a delayed action to unhide it. We're also transforming it specifically so that we can scale it. If you remember, one of the dimensions that we calculate was called scale, and so this is where we're applying that dimension. And then we're setting the content, which we had previously calculated when we created the raindrop in the create rain chain function. So here we're basically taking the content portion of the data and we are just applying it to the raindrop. And then we're attaching the raindrop to the container. And in this case, the container is the rain chain. And then finally, we have some delayed actions. And again, for the sake of being able to show everything on screen, the first two really could be combined into the same line. So the first one is taking the rain chain and it is making it visible. And then, sorry, actually that's the raindrop. So the specific raindrop, which started out as visibility hidden, it becomes visible. And then I've also got a transition statement here to say that that change should take place over half of a second. And then this line here is basically saying if we're not the first raindrop in the rain chain, then we want to go back to the previous one and we want to set an attribute. And so we're basically, what this is doing is this allows us to set the initial value as like a very bright, almost white green. But then when the raindrop is no longer at the forefront, it becomes a deeper, darker green. And so that's all that line is doing. And then here we're grabbing the raindrop and we are changing the opacity. So this handles the decay. So this is when the raindrop dies or disappears, dissipates. And so we're performing that transition over about 1.5 seconds, and we're transitioning to an opacity of 0. So that's it. And yeah, let me save that file and refresh. And maybe real quick, for the sake of demonstration, I'm going to maximize this and refresh again. And so there you see it in 4K. It may not be the most efficient implementation, but it was done in an afternoon in less than 100 lines, and it works. And maybe also, just for the sake of demonstration, I'm going to shrink this to a very small window, and we'll refresh it again. And so you can see all the mutated characters are more of a teal, and they have more blue to it, so that's what those are. And you'll also note that the bottommost raindrop on each of these rain chains is still green, but it's almost a white, just to accentuate and draw a little bit of attention to it. So that's the script. Thank you for watching.